All right, so today we start trigonometry. So we need to get trigonometry soaked into your brain a little bit today, because then on Friday we're going to hit it really hard and be finding angles and sides and all that. So today we're just working on figuring out ratios and how it works, and you need to understand what we're doing today really well, so then you can understand what we're doing on Friday. So if you just sort of get it, you really need to get it. Okay? So trigonometry is how sides of a right triangle are in a certain proportion. So let's say a right triangle has sides 3, 4, and 5. And it's angles A, B, and C. Okay? So if we're talking about angle A, I have relationships of, I can take the ratio of these two sides, or these two sides in relationship to angle A. And those relationships all come from trigonometry. So we have three main trig ratios. We have sine, which is abbreviated SIN, and the sine of an angle equals the opposite side from that angle over the hypotenuse of the triangle. Okay, sine is opposite over hypotenuse. Cosine is abbreviated cos. So the cosine of the angle equals the adjacent side to that angle over the hypotenuse. And the third one that we'll talk today about is tangent. And tangent is abbreviated tan of the angle. That equals the opposite side over the adjacent side. So then we have to figure out what we mean by opposite and adjacent and so on. So when you look at a right triangle, when we're doing trig, you always figure out where the hypotenuse is and figure out the hypotenuse first. So this is the hypotenuse, because the hypotenuse is opposite the right angle. Okay? Now, let's say I wanted the sine of angle A. Well, angle A is right here. The sine of it tells me that I want to have the opposite side of angle A over the hypotenuse of the triangle. The side opposite of angle A is 3. The hypotenuse is 5. So 3 over 5 equals the sine of angle A in this triangle. Okay? So you just have to know relationships of where certain things are at in a triangle. All right? If I want the cosine of angle A, that's the adjacent side over the hypotenuse. Okay? Adjacent side over the hypotenuse. So, adjacent is next to. Okay? It's not the hypotenuse. What's next to angle A that's not 5? 4 is. So it's 4 over the hypotenuse is 5. So that's the cosine of angle A. Finally, we have the tangent of angle A, which is the opposite side over the adjacent side. What's opposite of angle A? 3. and adjacent, 4, 3 over 4. So that's a tangent of angle A. So that's a trig relationships for that triangle when we're talking about angle A. Now, to help us remember what's sine, what's cosine, and what's tangent, we have SOHCAHTOA, which is Sacagawea's second cousin twice removed. And if you believe that, I've got some oceanfront property in Arizona to sell you too. Because there is no oceanfront property in Arizona. Okay? SOHCAHTOA is not some Native American that helped Lewis and Clark off across the nation. Okay? That's Sacagawea. SOHCAHTOA is sine equals the opposite side of the hypotenuse. Cosine equals the adjacent side of the hypotenuse. Tangent equals the opposite side over the adjacent side. That's what SOHCAHTOA means. It just is a mnemonic device that helps us remember sine, cosine, and tangent, and which sides are related to which. Okay, so let me draw another triangle. That's 3, 4, 5. Okay, now A, B, and C. Let's say I want the sine of B, the cosine of B, and the tangent of B. Before I figure out anything else, I got to figure out that Ryland is watching something on his computer and not paying a bit of attention, so he should shut his lid and take his earphone out so he can actually pay attention to what we're doing in class. All right. So when we're talking about this, we need to find the hypotenuse first. Okay? So 3, 4, 5, which is a hypotenuse? 5. 5 is the hypotenuse. Okay? So if we're talking about angle B, the opposite is 4, right? And sine is opposite over hypotenuse, so it is 4 over 5. Easy peasy lemon squeezy. This stuff can be really easy today if you get it down. Okay? This, some people go, that's not that hard. Nope, it's not that hard. You're just writing fractions today. All we're doing is writing fractions. And then we'll start applying it to angles on Friday and figuring out how angles work with it. Okay? Cosine of B is adjacent over hypotenuse. What's the adjacent side to B? 3. So it's 3 over 5. And tangent. Tangent is opposite over adjacent. TOA. So it would be what over what? 4 over 3. Okay. Before I can find sine, cosine, tangent, and all of them, I should do something first. What else should I do for this triangle? Find the missing side. Yeah, we got to find this side right here. C squared equals A squared plus B squared. What is that? What's C squared equals A squared plus B squared? Pythagorean theorem. So 13 squared equals 5 squared plus B squared. So 169 equals 25 plus B squared. So if we subtract 25, so B squared equals 169 minus 25, which is 144. Then take the square root. So B equals 12. So our missing side, side B, is 12. All right. So now that we know that, Sine of A. Well, that's opposite over hypotenuse. Which side's my hypotenuse, Brody? 13, exactly. So opposite of A over my hypotenuse would be what, Cohen? What is my fraction? Not 13 over 5. Opposite over hypotenuse. 5 over 13. There you go. Okay. Cosine of A is adjacent over hypotenuse. So what's my adjacent side and what's my hypotenuse, Miles? For A. That's 12 over 13. Tangent of A is opposite over adjacent. So opposite of A, adjacent to A. Shane. 5 over 12. Sine of B. That's the opposite side of B over the hypotenuse. So Molly, what's opposite over hypotenuse when we're talking about B? 12 over 13. Okay. Cosine of B, Kai. What's adjacent over hypotenuse when we're talking about B?
13 over 12.
Not 13 over 12. Because we have to find our hypotenuse first. Which one's our hypotenuse? 13 is our hypotenuse. So that's on the bottom. What's adjacent to B? What's next to B? The number? 5. So it's 5 over 13. And now the tangent of B. The tangent of B is the opposite over the adjacent. What's opposite over adjacent, Haley? What's opposite over adjacent as far as B goes? 5 over 12. Nope. 12 over 5. 12 over 5. Because we're talking about B opposite 12, adjacent 5. Okay? We're doing pretty good with this. Okay? Okay, we have a right triangle, MPQ. What am I missing? Hypotenuse. So C squared equals A squared plus B squared. So C squared equals 27 squared plus 36 squared. Gets to be pretty big numbers. 27 squared, I don't know what that is. 729. 36 squared. 1296. If we add them together, it's 2025. Now take the square root. What's square root of 2025? Square root of 2025. Is it 45? Okay, 45. So what's the sine of M? Well, the sine of M is opposite over hypotenuse. So 36 over 45. Cosine of M, Grace, adjacent over hypotenuse. What's next to M? What's the side next to M that's not the hypotenuse? 27. And the hypotenuse? 45. Tangent of M, which is the opposite over the adjacent. What's the opposite over the adjacent, Ryland? 36 over 27. Well, if I said the sine of P, Sophia, what is the sine of P, which is opposite over hypotenuse? What's opposite of P? 27. What's the hypotenuse? 45. There we go. Are we good with this? Okay. This won't take very long. I am going to just stop there. We are not going to have an assignment after lunch. This is our only assignment. Okay? And then, so if some of you still have to get your last Savas assignment done, which some of you have to still get your last Savas assignment done and turned in, get that done today too. Okay? I will hand out a worksheet, and the worksheet's easy. On Friday, we'll have a Savas homework, and